In this bonus learning objective, we're going to talk about special right triangles, and this was something that will come up in our next unit. All right, so in math, it's always important to recognize patterns and things that are going to make calculations easier or kind of save you time. One of these patterns has to do with special right triangles. So these right triangles have a very specific pattern to how they work. So the first one is when you have two 45-degree angles in the corners of your triangle. Because this is an isosceles triangle, it just means these two sides have to be the same. And then the hypotenuse ends up being the square root of 2 times whatever that side value was. So there should be an extra a there. All right, so that's one special right triangle, is that on a 45-degree right triangle, the two legs are the same, and that hypotenuse is the square root of 2 times that value. The other one is the 30, 60, 90. All right, this is 90. All right, that's a special right triangle. And the way I remember this one is across from the 30, across from the smallest angle, we have our kind of starting value. And the hypotenuse is double that starting value. And the other side is the square root of 3 times that starting value. So these I would just kind of have written in your notes, and we can reference them as we do the examples in the problem. All right, so for this one, find the exact value of x in this problem. All right, normally we couldn't do this because when you had to find a missing side of a triangle, you need two sides to use the Pythagorean theorem. We actually could do this with SOHCAHTOA as well, but we want to do it with special right triangles. So we know from a special right triangle is if both these are 45, the two legs are the same. So this is also x. So now I can do the Pythagorean theorem, x squared plus x squared equals 2 squared. That's 2x squared equals 4. Divide both sides by 2 to get that x squared by itself. And I take the square root of both sides to cancel out the exponent. So x is the square root of 2. So really for this one, I'm just remembering that when you have this special right triangle with the 45-degree angles, the two legs are the same length. All right, so here's one where we have a 30, 60, 90 triangle. And the way I remember this one is that across from 30 is the kind of starting value. The hypotenuse is double that value, so this is going to be 8. And the other side is the square root of 3 times the starting value. So here x is 4 times the square root of 3. You could also figure this out by just knowing the first two steps and use the Pythagorean theorem to get that missing side. All right, so here's one for you to try on your own. All right, find the exact value of x in this problem. And remembering for this one that because it's a 45, this is also an x. So you get the Pythagorean theorem that looks like this. I have to divide both sides by 2. And you get that x equals the square root of 11 over 2. All right, chances are if you type this into Desmos, it will not give you the right answer. It's just talk about the simplifying steps you might have to do at the end. So I had the square root of 11 over 2. One thing I always do with square roots is break them up over division bars. All right, so that's the first step. And the second step is I don't like having, I don't care. The rule is that you can't have square roots in the bottom of a fraction. So how do I get rid of a square root in the bottom? I just multiply the top and bottom by that square root I don't want. On the top, I'm just going to get the square root of 22. On the bottom, because I'm multiplying two square roots, they cancel out, and I just get 2. All right, so this would be your fully simplified final answer that Desmos would accept. Desmos, that Delta Math would accept. All right, so for this learning objective, you're going to complete some Delta Math problems. Are you going to complete 4 where you need an exact answer and 4 with a rounded answer? All right, but again, if you kind of have those special right triangles in your notes, just kind of follow along with the patterns, and you can figure out the missing side that you're looking for with the special right triangles.